All right. Thank you again for the invitation to be part of the class today. The presentation is called Hudson River Water Quality from CSOs to COVID-19. I am Dan Shapley. I'm the Water Quality Program Director for Riverkeeper. And go ahead and get started. So in this presentation, we're going to talk about some of the sources of water pollution in the Hudson River watershed in broad strokes. We're going to talk about how Riverkeeper measures water quality and go over some of the key findings from 10+ years of that water quality monitoring that we have been doing, and talk a little bit about how those findings are relevant today as we are currently where I sit in the center of the worldwide pandemic for the COVID-19 virus. Riverkeeper, to start us off, just to tell you a little bit about our history, Riverkeeper started with this pipe. This was an oil discharge pipe that was taking waste oil from the rail yard at the Penn Central station, not Penn Central station, the transfer station at Penn Central operated in Croton. That's still, for those of you who are in the New York area, still the same train yard that you would use as you cross from the to the local service in Croton, but at the time was operated by a different company, and they were discharging this oil directly at the mouth of the Croton River into the Hudson. And this was the kind of pollution that was rampant in the 60s at the time that Riverkeeper got started in 1966. But Riverkeeper, the founders found a law that had been on the books but not much used that outlawed dumping of this type into navigational waters. They dusted that law off. It was from the 1800s, and went to put it to use against this polluter. They won a bounty of $2,000, which they used to go after the next polluter and the next and the next, and in that way played their part even before the Modern Clean Water Act in stopping some of this egregious pipe pollution that at that time was rampant. And we still remain dedicated, I should say, to using the laws that are available to us as citizens in order to enforce our environmental laws. Second part of what makes Riverkeeper is this, the boat, our patrol boat. Captain John Lipscomb has been piloting that boat since the year 2000, and he takes it from New York City in the New York Harbor all the way up to Troy. That whole reach, 150 miles of the Hudson River, is tidal. It is the estuary part of our river. So it is intimately connected to the Atlantic Ocean, rises and falls with the tides each day. The fish that migrate into our river, in fact, right now as we're speaking, where one of the world's great migrations is underway, with fish from the Atlantic Ocean coming all the way up, in some cases 150 miles, to spawn here in the Hudson River and then return to the Atlantic to spend their lives and really feed that ocean ecosystem. So just like the river flows two ways, our patrol boat goes up and down the river. It acts as the eyes, the ears, the voice for the water, and a platform for science, as I will describe. The third part of our what makes Riverkeeper is community science. It's getting people engaged in measuring water quality. And that's really going to be the heart of what I talk about today. It's the part of the organization that I work on. So to orient us here, this is a map of New York State, and the Hudson River watershed is shown. A watershed is all of the land area that drains to a particular body of water. So in this case, the Hudson River drains from the high peaks of the Adirondacks in the north, central New York, as far as Rome, New York, in the central part of the state, and all the way down parts of New Jersey and in its easternmost part of the watershed, parts of Massachusetts and Vermont, and a little tiny bit of Connecticut. And all that water, all that land area drains down eventually to the Hudson River and flows out past New York City and northern New Jersey, and that is the Hudson River. Another way to think about it is that the health of that water, the Hudson River, is really made up of what water flows into it. So if this is the patient, then this is its circulatory system. These are all the smaller streams and creeks and rivers that feed into the Hudson River. And the health of that Hudson is only as healthy as all of that water that's feeding into it. So some of the sources of water pollution, again, really broadly speaking, that are important for the Hudson and many other bodies of water are these. There's runoff off the land as it rains. All of the water that hits the land and flows along it will carry with it contaminants that might be on the landscape. There's sewage, so our own waste that leaves our toilets in our homes and in our businesses and flows out through pipes and is treated, hopefully, and then discharged into the water. And then industry. And industry is both, at least for the Hudson River, is important both in the current sense that we do have current industrial uses of the river that are discharging some amounts of pollution under the Clean Water Act, but also legacy pollution. So we have contaminated sediments that are sources of industrial pollutants that are still very important in our river. So to break these down just a little bit, again, industry, if we just think about that, the PCBs is the thing that people are most familiar with as a contaminant in the Hudson River, and it's a very important and unfortunately persistent contaminant that affects the health of the fish for us to eat, and affects the ecosystem in that there's a lot of other life that depends on eating that fish as well. So these are toxic contaminants that are no longer in use, but are in the mud in particularly the northern reaches of the Hudson above the Troy Dam, and still affect the wildlife and the ecosystem throughout. But it's just one example. There are many others, and they tend to take the form of acronyms and are messy in your mouth to say, but are important to understand if we want to protect ourselves from effects of consuming contaminated drinking water or contaminated fish, or contaminating the environment with some of these chemicals that can be toxic. Another category to move on is the runoff. So again, the rain that falls on the landscape flows over it and carries contaminants with it. So that could be pesticides from farms and lawns, as well as fertilizers we use in the same landscapes, sediment and erosion, and pathogens as well, as I'll mention. And then the third category, sewage, pathogens, so things that can make us sick. Obviously, many of the things that can make us sick, we pass through our digestive tracts out into the waste stream, and if those make it into the water, we can then become sick again if we're exposed to those same pathogens in the water. That's what we're going to focus on a lot in this conversation today. But there are other things in that waste stream: pharmaceuticals, personal care products, and a category that a lot of people don't realize, but industrial wastes. A lot of the Clean Water Act stopped discharges or required permits for direct discharges to waterways from factories and other industrial sources of contaminants. But where there are public sewers, those discharges in many cases are continuing to today. They just go through the public sewers first. So a lot of people don't realize that. So I always like to mention it, that sewage is a complicated set of contaminants. So we started our sampling program with the questions of folks like these in mind. These were people who John, our captain, was meeting on the water, and they were saying to him, how's the water? And their question was really very basic. It was, am I going to get sick if I do this thing I want to do, which is swim, or jet ski, or tube, or splash around at the water's edge, kayak, all of the things that we love to do in water. Humans are naturally drawn to water. We want to be in it, we want to be near it, we want to be on it. And that, I believe, is a natural and a human right to have that access to water that we can enjoy, and not be threatened by that pull to the water. So if you do want to measure water quality in a way that will give people who are using the water the information they need to understand if they're putting themselves at risk by swimming or other activity like that, what you want to know is, are there pathogens from sewage in the water? This is an important question for the Hudson River, because we have over almost 350 million gallons per day of sewage that is discharged through treatment plants into the Hudson River or its tributaries from that whole watershed that I described before. That's before you even get to New York City. And then in New York City itself, another 1.3 billion gallons of sewage is discharged to the Hudson, the East River, and other waters. I didn't have figures at my fingertips, but then there's also discharges from northern New Jersey into that last stretch of the Hudson River. So there's a lot of sewage that we ask this river to accommodate. And if we are treating it, no problem, really. We are removing the pathogens, at least. That is the basic goal of sewage treatment, is to remove anything that's going to cause diseases, as well as odors and other nasty things that we don't like about sewage. But the main goal is public health. It's trying to prevent the downstream spread of illness that might be associated with our waste stream. Now, the problem is not all of it is treated consistently all the time. So we have sewer overflows, including what are known as combined sewer overflows from many of our oldest communities, of which we have a lot in New York, were built with pipes that carried the stormwater from rain as well as the sewage from our toilets. And so when it rains a lot, that sewage overflows along with the stormwater right into our river and some of its tributaries. We also have very old infrastructure. So a lot of these pipes were put in at the beginning of the Clean Water Act back in the 70s and early 80s, and many of them even earlier. So all of that infrastructure is aging, and it is leaking, it is prone to overflows, and it is a major expense. You know, $80 billion estimated need in New York State, the largest in the nation, for upgrading sewer and drinking water infrastructure. And so as that infrastructure ages, we have greater risk of sewage that is not treated entering the water. And then we also have what I would call inadequate treatment, which I'll touch on just a little bit, in that we think of disinfection as a modern key part of treating sewage effluent. But we actually only require that in New York State of many plants during the warmer months when people are using the water. So we treat sewage in other ways, but we don't disinfect it to kill the pathogens, except from May to October at many locations. Some plants, the largest plants, have to disinfect year-round. Plants that discharge near drinking water sources have to disinfect year-round. But many treatment plants around the region do not have to include that stage of treatment currently as we speak here in April, and they won't have to until sometime in May. So all of that means is that the pathogens that are associated with sewage can and do enter the water. And pathogens, when I say pathogens, what I mean are viruses, protozoa, it's harmful bacteria, things that if we are exposed to them, they can make us sick. And the general rule of thumb when you come to water is if you are immersing yourself fully in the water, or you're getting water in your mouth, then that's the risk of exposure to these pathogens. So swimming, but also other activities like jet skiing, or tubing, things where there's a lot of water spraying up in your face, things like that are also equivalent when it comes to risk. So we can't measure all of those things, all of those, that stew of pathogens and other things that are in sewage, that's beyond our capabilities to measure comprehensively. What we do is measure a single type of bacteria, and we call those fecal indicator bacteria, and they are studied over decades to tell us that when present, the pathogens that can make us sick are likely also present, and there is therefore a risk if you are using the water. So everything I'm going to be talking about from here on out is our understanding of water quality through the lens of our understanding of these fecal indicator bacteria. Now, one complication, you might have seen the runoff bubble there turn green. One complication I'm not going to touch on beyond this slide is that those same bacteria that are associated with sewage and can indicate when pathogens are present also are present from other sources, and they can be present in runoff that comes from other things that are unassociated with sewage. So it's not a perfect indicator. It's not without its complications, but it's the best that we have currently. So how do we get that data? We go out and we dip bottles in the water, and this is Carol Knudsen. She's a researcher associated with Columbia University's Lamont Doherty Earth Observatory. And Lamont, as well as Queens College, have been Riverkeeper's partners since 2006 in designing and implementing the project that I will be describing and the findings that I'll be describing. So she goes out with our boat captain, John, and grabs these water samples. To zoom back out to our watershed map, remind us the river that we're talking about. So there is a question I see, runoff, industry, and sewage. The question is, are these point sources of pollution? So sewage is generally a point source because it comes out of a pipe, and we try to treat it, hopefully all the time, but as I suggested, not 100% consistent on treating all of the sewage that enters the water, but it is a point source. Industrial pollution is almost always also a point source in that it is chemicals are used at a particular facility and discharged, and they become a point source through a pipe to the waterway. But runoff is a non-point source. So runoff is all of the water that runs off the landscape, and then the rainwater that runs over the landscape and washes contaminants that are on the land and on our pavement and on our farms, on our lawns, washes that into the water. So that's what's considered non-point runoff, non-point pollution, I should say. So back to our sampling protocol and our sampling design. Here's the Hudson River watershed, and I'm going to jump a different type of map quickly, but these black dots show on the Hudson River itself the places we've been sampling, 74 of them since 2008, consistently every month, May through October. So over that time, we've gathered over 5,400 samples from these locations. And with that information, learned a lot about patterns of contamination that tell us a lot about water quality in the Hudson. We use this key to sort of hopefully make it simple to understand what these results look like. This you'll recognize, it's the traffic light kind of framework. Red is the bacteria levels that we measure are at a high enough concentration and frequently measured at a high enough concentration that they exceed the Environmental Protection Agency's criteria for safe swimming. And so that is a location where we can't recommend swimming because the contamination is too often too unsafe to allow for safe recreation like swimming. Yellow is generally in dry weather. There's conditions that are going to be fine for swimming and similar recreation, but after rain, which is as little as a quarter inch of rain cumulative over 3 days prior to the sampling that we do, in those conditions after rain, we tend to see poorer water quality and it gets riskier. So after rain, that's where the risk is associated with that yellow category of sites. And then green, these are the ones we'd like to see everywhere. This is where swimming is generally safe, and we're not measuring the indicator bacteria at concentrated levels persistently, so it's generally safe. So we can look at categories of sites that we've sampled. Among those 74 throughout the river, we have divided those into 3 different types, one of which is the middle of the river. So I have this kind of crude diagram at the right and a pie chart showing you that in the middle of the river, away from the shoreline, we often see water that is safe for swimming in most locations. And in fact, the only places where the water quality is not meeting those standards or that criteria, I should say, is near the capital district, where we have a lot of combined sewer overflows, over 90 of them from 6 different communities. So every time it rains, there's a really significant discharge of untreated sewage in that upper part of the Hudson River near Albany, Troy, that area. And so all of these reds and yellows are really in that upper 20 miles that's right in that reach. So generally in the middle of the river, away from the shoreline, we see pretty good water quality, except for that area and some areas around New York City. Now, if you look to the edge of the river, the near shore areas, the picture is a lot different. We see still a lot of places that are good for swimming and generally safe, but a lot greater rain impact. So not surprisingly, with runoff being a source of contamination, that rain carries with it often enough contamination to cause risky conditions after rain in a lot of our near shore. Then as we get into the tidal tributaries, so these are the parts of each of the creeks and the smaller rivers that meet the Hudson but are still tidal, still part of our Hudson River estuary. Where we've sampled in these areas, we see no place that is safe for swimming all the time. And in general, we see a lot of rain impact in some places where even in dry weather, we don't see conditions that are generally safe for swimming. So just to zoom back out and to see them, the 3 of those categories next to one another, so you can kind of just get a sense for the variation. This tells us important insights into the patterns of contamination that we see in the Hudson, where we have made the progress that we would have expected 30, 40 years after the establishment of the Clean Water Act, and where we still need to make progress to continue to improve water quality. Now, the last finding around the tributaries led us into a whole project to expand our sampling network with the help of individuals who are volunteers in a community science effort to measure water quality in many of the rivers and streams and creeks that feed into the Hudson. So these black dots show that many of those locations, over about 400 of them that we've been sampling on a regular basis over time. Now, this chart, I don't expect you to make sense of the numbers, but this shows for each bar on this chart is a different creek or river that feeds into the Hudson River, different tributary. And what I want you to take away from this is that the contamination levels can often be very high. That red line is the safe swimming line by one measure of EPA criteria. So the levels can be very, very high, and there's also huge variation among the tributaries. So we see widely varying conditions in different creeks and rivers that feed into the Hudson. I know you all are from SUNY New Paltz, so I'll just point out the Wallkill River is towards the middle right hand of your screen, and there's number 502 is over it. So the Wallkill River became a concern of ours as we started to test it, because as particularly as a big river relative to a lot of the tributaries that we're sampling, we were seeing very, very high numbers here. So I'm not focusing today on our efforts on the Wallkill River, but we have put a lot of effort there, and there's a strong local group, the Wallkill River Watershed Alliance, and recent, in the last couple of years, strong effort from the State Department of Environmental Conservation to focus on water quality improvements in the Wallkill. So while the Wallkill's got a long way to go, we have given it finally its first steps forward to really improve, and it all started with the data collection that really got people aware of the severity of the problems and galvanized support for solving them. So I see there is a question that asks, are there any indicators that help determine is water safe or unsafe for swimming without testing it? Well, not directly. There is a law that we helped to pass in 2012 called the Sewage Pollution Right to Know Act, and you can sign up for alerts. It's a state law, and so in New York State, you can sign up through the NY alert system, which you can also use to get alerts on weather hazards and traffic delays, you know, if highways are closed, things like that, a whole range of conditions. One of them is to alert you if there's been a discharge of untreated sewage to the water. And so that is another way that you can start to get a sense for when and where there might be issues. But we also know from our own testing that that is it's not, that will only tell you some of the times when it's unsafe. And you can't always tell from looking at the water. Certainly basic common sense does help. If the water looks cloudy and smells bad, you know, or you're near a pipe, you know, those are obviously good times to avoid excessive contact with the water. But you can't, unfortunately, rely on any real-time test that you might have in your pocket or just a visual appearance to make that kind of choice. Wish it were so. So to summarize very broadly about what we've learned, pathogens from sewage are present in parts of the Hudson River and its tributaries. I described some of those patterns in more detail, but if you really zoom out, that's a very, very simple statement that describes our findings. Now that's particularly relevant right now because the COVID-19 virus, at least its RNA, so its genetic material, has been found in human feces and in sewage. Other coronaviruses, so COVID-19 is one of several known coronaviruses. So others of that type have been found in water affected by sewage and have been found in aerosols associated with sewage. And those have been found to be infectious at times. Unlike the first bullet point here, when you find the RNA or the genetic material of a virus, that form of testing doesn't tell you whether it's infectious or not. It could be essentially dead virus or infectious. But the other coronaviruses have been detected and been shown to be infectious in this pathway. We have, through our own research with partners, seen that other pathogens have been found in aerosols associated with sewage contaminated water in the Hudson River around New York City. So that means, another way of saying that is what contaminants are in the surface of the water are also in the air above the water. So these understandings, these basic findings from some of the science that has been done, and we have to ask, is the COVID-19 virus in the water where we measure the fecal indicator bacteria that I described in this presentation? Is it in the air where there's heavy sewage contamination? And in either case, is that infectious virus or not? So we don't know the answers to those questions. But we have taken those basic facts into account in our initial response as an organization to the pandemic that we're currently living through. So one thing is we're postponing any community science water sampling projects. Normally we'd start in May, and we are at least not starting in May. We would have to see, we work with a lot of universities and they're all closed. You're hearing from me remotely, and you're not the only class that's out of session. They're all out of session, and the scientists we work with can't use their labs. So we have a big barrier to executing some of our projects because of that. But more fundamentally, there could be a risk to people going out and taking water sample in places that are heavily affected by sewage, and we don't want to put people at risk, even knowing there are uncertainties and that we're not certain how important a risk that is at this stage. And thirdly, we are concerned, of course, that we want to follow the pandemic science. We honor science and public health science, particularly with this project. And so the science around pandemics tells us to stay home. So we want to respect that and adhere to it. So we're postponing our science projects for the time being. We're also going to be advising the public to avoid contact with water that may be affected by sewage that it has not been treated or which has not been disinfected. And that's for all the reasons that I just described. And we hope that our data that we have gathered and those patterns that we've been able to describe in the Hudson River help people to make informed choices if they do want to go to the water, because we are being encouraged to go outside and enjoy space from people, but enjoy the outdoors. So we want people to do that at the river and its tributaries if they can do it safely. But we don't want them to do it if it's going to put them at risk. So hopefully we can help to point out areas where there's greater risk where there is greater likelihood they can avoid any risk. We also want people to be aware that drinking water should not be affected. And that is because our best understanding of these viruses is that chlorination and other disinfection effectively kills or renders inert these coronaviruses. So drinking, unlike sewage treatment, which is uneven on its use of disinfection, drinking water treatment is generally very consistent in New York State. And in public drinking water supplies are using disinfection as a basic form of treatment, and that is proved to be reliable largely, on a broad scale. So people should not be looking at their tap water with any undue concern as far as we understand for the COVID-19 virus. And the other thing is we are seeking funding. We're trying to find money so that we can answer some of those questions that I posed in the last slide. Is the COVID-19 virus getting into our water? Is it in the air associated with that contaminated water? And in either case, is that virus infectious? Those are, to me, the three key questions, and we want to try to answer them with the scientists that we work with if we can find the money to do so. And finally, what this all highlights is a point that we make over and over again at Riverkeeper, which is just that it is hugely important to upgrade and improve our wastewater infrastructure. When we have 350 million gallons of sewage being discharged into our Hudson River and its tributaries every single day, making sure that that sewage makes it from our toilets to the treatment plant and is effectively treated before it gets discharged to the water is critical for the health of the river and for public health. And this pandemic, whatever the actual risks turn out to be from this water transmission route, it highlights the critical public health function of sewage treatment, the sewage treatment plant operators who are out there and unsung every day doing this work. They're in this category of essential workers that we've been hearing a lot about. We don't think about them a lot, but they are doing incredibly important work to keep us safe. So we are always advocating to get more money into the system for this public infrastructure. And I will say that in the budget that New York State just passed a day or two ago, there's $500 million in new funding for the Clean Water Infrastructure Act, which is a very important, relatively new source of funding for this important category of public health and environmental protection. So with that, I will give you our web address. I'm going to stop the video and then open up the lines and take audio questions if